YouTube Dare problem on a math channel, and what you see right here is a special case for n equals 7 of what you see below. Okay, now it's clear that this particular problem is in this form right here for n equals to 7, right? Now another thing to notice is that n factorial is clearly the least common denominator, right? And also you can rewrite n factorial following way. N factorial is equal to n minus 2 factorial times n minus 1. Now this is just a useful thing to write down as far as finding the combining this fraction into a single fraction. Okay, no doubt about this, folks. N factorial is just 1, 2, 3, 4, 5, 6, 7, all the way out to n. And so this is n minus 2 factorial, and if you tack on n minus 1 and n, you get n factorial. Now that's useful on this very next line. And I've done most of the work just so I wouldn't have to write it all down. But notice right here, this is just all fairly basic stuff. I like showing this step. A lot of teachers will leave this step out and just go straight to this step. But in any event, you see that you end up with n squared plus 1 is equal to 1 over x. So you see we clearly can get x in terms of n here. All right, in fact, if you reciprocate here, we see that, excuse me, we see that x is just equal to n factorial over the sum n squared plus 1. Just reciprocating, right? Now again, as we mentioned, n is certainly equal to 7 right here. So we can write this as I'll just write it out, I guess, 1 times 2 times 3 times 6 times 7. And then this would be over 50. But notice that 50, see 7 squared is 49 plus 1 is 50. So this would be 2 times 5. Got it? Okay. And so a little bit of arithmetic is going to be required right here, but we can see, or 2 times 5 squared, excuse me. 2 times 5 squared. So from here we'll see that x is equal to, what do we have? This 2 cancels with this 2, so we have 3 times 4. We have 3 times 4 right here. And then what else cancels here? Okay, so we have the 2, excuse me, this 2 cancels with this 2, then we have 3 times 4. One of these 5s is going to go away, so you're going to have 6 times 7. All over 5. And 3 times 4 is 12. 6 times 12 is 72. 7 times 72 is 504. It's 490 plus 14, right? So you would get 504 over 5. It's the final answer here. There we go, folks. That's how it's done. But the nicer result here is that we just have this general expression, really. This is really what I think is nicer about the whole thing, rather than just the crunching out arithmetic. We know that x is always going to be n factorial over n squared plus 1 for anything in this form.